Hi, this video will demonstrate how to evaluate a function graphically, and then we'll also talk about the domain and range of a graph function. So here in the graph, I have the graph of what I'm going to call f of x. Okay, and it's graphed here in orange. All right, so the first thing we want to do is evaluate f of x at some given x's. So the first one I ask is f of minus 2.5. The way you're going to use the graph to do this is you go to minus 2.5 on the x-axis, because remember this is f of x. So when I write f of minus 2.5, in place of the x I put a minus 2.5. So we're going to go to minus 2.5 on the x-axis, okay, which would put me here. I'm going to jump up to my graph, to the orange part in here. And then what I do in that case is I'm going to read off the corresponding y value. So f of minus 2.5 is 3. Okay, let's try another one. F of 0, I'm going to go to 0 on the x-axis. Well, that's just the origin. Okay, I'm going to go down to my orange curve, okay, which is here, and read off the corresponding y value. And here it is negative 3. Okay, right here. The last one I have is f of 3. So in this case, I go to 3 on the x-axis, which will put me here, go to my curve, which will put me here, and read off the corresponding y value, which in this case is 6. So that's how we use a graph to evaluate a function. Now let's talk about the domain and range. When you see domain, you should think x values, or in other words, all valid x inputs for this function. On this particular graph, I have a solid circle here and I have an arrow going off here. The solid circle means that my function stops here at negative 3. So when we get ready to define the domain, I'm going to define it as d equals, all right, x such that, all right, I want to first put the smallest value x can ever take on. Here is my x-axis, all right, here is my graph of f of x. The smallest value x will ever take on, of course, is right here, and that is minus 3. So minus 3, less than or equal to x. All right, and then I want to put the largest value x can take on. Well, graphed here, it's 5, but I have this arrow, and the arrow means that this will continue off for forever. All right, so this will go off, off, and off, so the largest value x will ever take on is actually infinity. So that is my domain. Okay, you want to put the smallest value x can ever take on, and then the largest value x can ever take on. A solid circle here means to include this endpoint, so I've put an equal signs with my negative 3. If it happened to be an open circle, you would not include the endpoint, so you would just have the less than sign. You would not have the equal sign. All right, now let's look at the range. When you see range, you think y values. Well, where do we find the y values on a graph? Well, we typically find them along the y-axis, right? So I'm going to do the same thing for my range. The range in this case is going to be y, such that, all right, now I want to put the smallest value y ever takes on. Well, that's here. The smallest point for y is right here, and that's a negative 3, less than or equal to y. And now what's the largest value y can ever take on? Well, graphically it's gone all the way up to 21, but this graph again goes up and up and up and up and up off to forever, okay? So the largest value it would ever take on is infinity. So that's how we use a graph to evaluate a function and determine the domain and range.